Okay guys, today we're going to be learning about dilations on the coordinate plane. These actually are quite a bit easier than like rotation, so I don't think you'll have any trouble with this. By the end of this lesson, you should be able to describe the effect of dilations on a two-dimensional figure using coordinates on the coordinate plane. Here's your definition, which you might find on the note check, of course. A dilation is a transformation that enlarges or reduces a figure by a scale factor, which you may have remembered from last year in geometry. Translations, remember, are slides. Reflections are mirror images. And dilations either make things bigger or smaller. Same shape though, okay? When the center of dilation is the origin, so 0, 0, you can find the coordinates of the image by multiplying each coordinate of the figure by the scale factor. Use this notation, x, y, becomes kx, which means multiply by, and ky to describe the dilation. K is your scale factor. So let's look at an example. A figure has these vertices: J, 2, 4, K, 2, 6, M, 8, 6, and N, 8, 2. Graph the figure and its image of the polygon after a dilation with a scale, that's a typo, scale factor of 1/2. Okay, so that just means take every coordinate. So let's go J prime, K prime, M prime, and N prime. And we are multiplying each coordinate by 1/2. So J would be 2 times 1/2, which is 1, and 4 times 1/2, which is 2. Okay, so I'm just timesing by 1/2 every coordinate. Okay, K prime, 2 times 1/2 is 1. 6 times 1/2 is 3. M prime, 8 times 1/2 is 4. 6 times 1/2 is 3. N prime, 8 times 1/2 is 4. 2 times 1/2 is 1. That's it. So this is making it smaller, obviously. So every coordinate was times by 1/2. Okay, and then you can graph it. The dilation is xy, 1/2 times x and 1/2 times y, which multiply the coordinates of each vertex by 1/2, and then graph both figures on the same coordinate plane. You can check these here with the ones that I just did. 1, 2, 1, 3, 4, 3, 4, 1. Yay, gold star. You try, okay? This is where your note check comes into play. You go ahead and try it right here. Okay, list your coordinates first. So like R prime, S prime, T prime. Scale factor is 1/3. So you'll be timesing by 1/3. Okay, don't use decimals, use fractions, because you don't want to deal with decimals on the coordinate plane. Example 2. Okay, a triangle has vertices of A, 1, -2, B, 0, 2, C, -2, -2. Find the coordinates of the triangle after a dilation with a scale factor of 2. Okay, the scale factor is 2, so it's going to be bigger. It's going to get bigger. So you want to multiply the coordinates of each vertex by 2. So times everything times 2, and these are your new vertices. When you graph it, you'll see that your new one is bigger than your original. Okay, you try. This is again on your note check. This one right here, note check. You're going to want to show me your graph when you're finished. You want to have an x prime, a y prime, and a z prime. You are multiplying by a scale factor of 3, so everything times 3. And then list your new coordinates, show your original and your new on the graph. And then this is also a note check. Okay, and this time you're using a scale factor of 2.5. Okay, key concept, finding scale factor. Sometimes you're given a dilation and you need to find the scale factor. First of all, an enlargement is anything with a scale factor bigger than 1. K is your scale factor. A reduction is when K is between less than 1 and greater than 0. Okay? you aren't going to have anything less than 0. You can't have a negative. Okay, the same as the original is if k is equal to 1. That means it's exact same shape. Okay, so in words instead of symbols, a figure has been enlarged, its scale factor is greater than 1. If it has been reduced, the scale factor is between 0 and 1. When the scale factor is exactly 1, the size and the shape do not change. To determine the exact scale factor, use a ratio. The sides of the image of a figure being dilated are proportional to the corresponding sides of the original figure. So we'll be using proportions to solve this. To determine the scale factor, write a ratio comparing a side length of the image to the corresponding side length of the original. Let's do an example. A drawing of a school mascot is to be enlarged as shown at the right so it can be painted on the gym doors. What is the scale factor of the dilation? Write a ratio comparing the lengths of the sides of the two images. Subtract the x-coordinates to find the original length. So all they did was take 3 and 1 and 9 and 3. Those are the x-coordinates of the new to the original. So they did 9 minus 3, which equals 6, over 3 minus 1, which equals 2. And 6 divided by 2 is 3. So the scale factor is 3. It's enlarged by a scale of 3. For the last part of this note check, you're going to be wanting to do scale factor. And let me just kind of help you out setting it up. If you want to reduce an 8 by 10 photo to 2 by 2.5 inch photo, to find the scale factor, set up a ratio of the proportional sides. So like if you were to draw this, you might have an 8 by 10, and then you're making it smaller to 2 by 2.5 because the 8 matches the 2 and the 10 matches the 2.5. So if you want to find, since it's a reduction, put the small number on top and the bottom one on, or the bigger one on the bottom, and that will give you your scale factor. Make sure to simplify. Okay, and you'll do the same thing for the bottom one. All right, if you have any questions, please make sure to ask. Bye for now.